For section 1.4, we're going to look at the properties of real numbers. And we're going to look at how those properties can aid in the simplification of expressions, much like the order of operations can. If you'll remember from your previous algebra classes, the properties of real numbers are really, much like the order of operations, just a set of rules for us to follow. So that way everybody, remember mathematics is a common language throughout the world, that way everybody is following the same rules, quote unquote, if you will. So these are the 6 properties you're going to be tested on in this unit. So let's go over these. The associative property is a property that states that certain numbers can be associated with each other and still get the same answer. So let's take 4 plus 3 times 2. The associative property states that if you move those parentheses from the 4 plus the 3 and move it to the 3 plus the 2, you're still going to get the same answer. This would be 7 plus 2 is 9. This would be 5 plus 4 is 9. So the answer remains the same even though you're associating with different people. Now the way that I want you to remember this is how I just said it. The associative property says that it's okay for this 3 to associate with different people. Here he's associating with the 4. Now he's going to associate with the 2. And we're still going to get the same answer. So the associative property says it's okay to associate with different numbers. Now let's look at the commutative property. The commutative property states that when you're adding and multiplying, the order of the numbers doesn't matter. So 4 plus 2 is going to be the same as 2 plus 4. So for the commutative property, what I want you to remember is that the order of the numbers will commute or move. How do you get to school every day? You commute to school, you drive to school, you move to school. The commutative property says it's okay to move. Now I want to look at the similarities and differences between associative and commutative. Notice the order of the numbers is not changing. There's no commuting going on in the associative property. We've got 4, 3, 2, 4, 3, 2. The associative property does not say that you can move the order of the numbers. The commutative property says you can change the order of the numbers. And that's how you know the difference between the two. Now the inverse property, I want you to think of inverse property as the property that cancels things. And we're going to look at this 2 different ways. First of all, if I wanted to cancel the number 4, I would add the opposite, or a negative 4. What's 4 plus negative 4? 0. We canceled it. Likewise, if you're looking at it from a multiplication perspective, how would I cancel a 4 from a multiplication perspective? I would multiply it times 1/4. That would get me a 1. 4 times 1/4 is 1. You would cancel it. And remember, in the multiplication world, canceling is a 1. In the addition world, canceling is a 0. So I want you to remember the inverse property as the property that allows us to cancel numbers or get rid of numbers if we need to. The identity property keeps a number's identity. I want you to think of the word identity. How can you keep your identity? Add nothing to it. It will remain itself. It will keep its identity. It's the identity property. How can the 4 remain a 4? Add nothing to it. Now let's look at it from a multiplication perspective. How can a 4 remain a 4? Times 1. Anything times 1 remains itself. These are the identity properties. This says how can we keep a number itself? We can keep a number's identity by adding 0 or multiplying it by 1. Distributive property is a property that states you can get rid of parentheses in a different way if you need to. Let's look at this particular problem. Let's say I have 4 times x plus 2. Well, our order of operations tells us you got to do parentheses first. We need to do this x plus 2 first. We can't. What is x plus 2? I don't know, because I don't know what the x is. So in other words, we can't get rid of those parentheses. So the distributive property was developed as a way to get rid of parentheses when we need to. So instead of adding the x plus 2, since we can't, we're going to take that 4 and we're going to multiply it into the parentheses. So 4 times x is 4x. 4 times 2 happens to be an 8. And that's our distributive property. Multiplicative property of 0 states that if you take any number times 0, no matter what that number is, it will be 0. 0 times 0, 1 times 0, 4 times 0, negative times 0, fractions times 0. Anything times 0, it will remain 0. And those are your properties of your real numbers. I want to go ahead and dive just a little bit deeper into the concept of like terms and this distributive property. I want to work with that a little bit. You are tested on both of these concepts, which both should be familiar to you, but I want to work with them just a little bit. It's going to lead directly into Unit 2, which is solving. Let's say that I give you this problem. This is negative 2m plus 5m plus 3 minus 6m plus 8. Let's say that I give you this problem and ask you to simplify. When I ask you to simplify, what I'm asking you to do is put all like terms together. I want you to put all like terms together and simplify this as much as possible. So the first thing we need to do is identify what the like terms actually are. In this case, the negative 2, he has an m. The 5 has an m, and the negative 6 has an m, making them like terms. Remember, the definition of like terms are terms that have the exact same variables. The positive 3 and the positive 8, they're like terms. They don't have m's, they don't have variables, so they're like terms for that reason. Before we start to put this together, I want to point out two things. Number one, we need to always write our answers in descending order by degree. This is m to the 1, m to the 1, m to the 1. This is technically m to the 0 and m to the 0. So the m to the 1s need to come first. We always want to go in descending order. The second thing I want you to remember, and this is the most important, we are not going over an equal sign. We're not solving. There is no equal sign in this problem. So it is absolutely unacceptable to do the opposite. For example, if you're saying, I've got a negative 2m, okay, great, I need to add 2m. That would be incorrect. We're not going over an equal sign. We don't have to do the opposite. This is an additional step we don't need to do. Or for example, if you would say, hey, this is a positive 3, I need to subtract that 3. That would be incorrect. We don't need to subtract that 3. We're not going over an equal sign. So when we put our like terms together, we quite literally just put them together. Negative 2 plus 5 is 3. 3 minus 6 is negative 3m. Excuse me, let me rewrite that. So let me say that again. Negative 2 plus 5 is positive 3m. Positive 3m minus 6m is negative 3m. So what I've done is I've taken all my m's and put them together and created one. I've simplified it. Now I need to put my second set of like terms together, which is the 3 and the 8. They're both positive. 3 plus 8 happens to be 11. My answer is finished. It's a positive 11, so put a plus 11. All right, let's go ahead and look at a different type of problem. 3x plus 4 minus 5 times x plus 1 minus 8. This is a little bit more complicated problem because what I've done is I've thrown in some order of operations. Now remember, our order of operations says you've got to do grouping symbols before you can simplify the rest of this. And I've got a grouping symbol right here. It's parentheses. What is x plus 1? Shoot, I don't know. We can't put x plus 1 together because I don't know what x is. I could do x times 1, but I can't do x plus 1. In this case, we've got to revert to our distributive property to get rid of those parentheses. Order of operations says you got to get rid of the parentheses. I can't without using the distributive property. So what I'm going to do is I'm going to take that negative 5 times the x, and I'm going to take that negative 5 times the 1. Remember, that negative sign belongs to that 5. So what I have is 3x plus 4, negative 5 times x is negative 5x, negative 5 times positive 1 is negative 5, minus 8. So what I've done is I've multiplied that negative 5 in and simplified that and gotten rid of parentheses. This is not completely simplified because my like terms are not together. I need to identify my like terms and then put them together. I notice I've got a 3x and a negative 5x. Those are like terms because they both have an x. I've also noticed that I've got a 4, a negative 5, and a negative 8. Those are like terms because they have a common variable, which is nothing. They don't have a variable. Which would I do first? My x's. Remember, we want to go in descending order. My x's have a higher degree than my constants, so I'm going to put my x's together first. What is 3x minus 5x? What's negative 2x? What is 4 minus 5? Negative 1. Negative 1 minus 8 is negative 9, leaving me with negative 2x minus 9. Now that's as simplified as I can go. I can't put those together because they're not like terms. Last but not least, I want to look at kind of a funny problem. Let's look at this problem. Okay, first of all, order of operations once again tells us we've got to get rid of grouping symbols first, and I have some grouping symbols here. Well, what's 3m plus 2? I don't know. I can't put 3m plus 2 together. I need to get rid of it another way. And remember, the only other way we know to get rid of parentheses is using our distributive property. The problem is I don't see anything to be multiplied in. Technically, in this case, that -1 needs to be multiplied in. Wait, what -1? This is a -1. Now, the 1 is silent, it's not written, and that's okay, but that is a -1. What I tell my students is you have the option of going ahead and writing in that -1 if you need to. If you're okay seeing it just as a negative sign, you can do that too. But basically, that's a -1 that we need to multiply in here. So 8, what's -1 times 3m? -3m. What's a -1 times a +2? -2. Oops, don't need that. Now, we're not done until our like terms are put together. So I've got a like term of a -3m. Wait a minute, he doesn't have anybody to go with, and that's okay. I've also got some like terms of an 8 and a -2. Which one comes first? Well, the -3m needs to come first because he's got the highest degree. 8 minus 2 then is +6, and so I put a +6 because it's a +6. -3m plus 6 is my final answer.